do, though, I'm going to have to give you a very nice, amazing area formula. You go, area? Yes. Now, I'm going to do it. I'm going to give it to you the way the book does. And say, here's my angle here, ladies and gentlemen, theta. And what your book is going to do this. It's going to call this side B and this side A. All right? So here's a side A. Here's a side B. And they gave us an angle between them. And let me kind of remark about this. This is an important detail. For this triangle, note, it's not a right triangle. So say right triangle, no. What's a non-right triangle? Does anybody remember from geometry? That has a name. What is it called? It's not right. It's a non-right triangle. And by the way, this is also called, you're going to get used to this language. The angle is between two sides. Is that true? So this is called side angle side. I want you guys to know what that means. You got two sides and the angle is between them. Side angle side. Okay, you guys okay with that? So what is a non-right triangle known as? Oblique. This is an oblique triangle. Okay. What I'm going to do is I'm going to bisect it here, and this is going to be known as H, okay? I call that H. Does anybody happen to know why I call this H? Isn't that the height of your triangle? So I'm going to create the height here. Now, you might say, well, what does that even mean? Well, what do you guys know about, I should say, triangles in the area? In the area, 1/2 base times the height. Is that true? But in this case, what did we call the base here? Is that A? And then what's the height here? Is that H? You guys with me on that? That's, again, also from geometry. So this is the height. Yes? Nope, nothing squared. It's just what we're saying here. If you remember from geometry, if you have a triangle here, we're going to call that in gray. What's the area formula? It's 1/2 base times height. Okay, you guys okay with that? Isn't the area formula for a triangle 1/2 base times height? Okay. Now in this case, what's the base? They called it the letter A. And what's the height? It's the letter H. But you guys want to know something about H? Here's going to be the thing. Isn't it true? Sine of the angle theta is going to be what? Opposite over the what? Hypotenuse. I want you guys to focus right in here. This is my point to you. Isn't sine of that angle theta opposite? What's the opposite side? H. What's the hypotenuse of that triangle again? That triangle on the right side, isn't that B? Yes. Now, what does that mean about H, ladies and gentlemen? I can solve for H. Now, H is going to be B sine theta. This is an important detail. I can replace my h. I can substitute h with what? B sine theta. So you have AB, 1/2 AB sine theta. This is the area, ladies and gentlemen. This is an area formula for a triangle. But what you need is this information now. You're going to transition. You're going to transition from the 1/2 base times height formula. Now, it's going to be simply what? 1/2 AB sine theta. So you do have to know what A is, you have to know what B is, and you have to know this applies to what kind of triangle here. Not a right triangle, because that's not a right triangle. I'm going to erase this. This is really a what? What is this really? If I look at it now, this is a what kind of triangle? This is an oblique triangle. It's the name of a non-right triangle. But again, it needs to be, what's this called? Side angle side situation. So, you know, for an example here, they can say determine the area. And they'll give you information like this. They'll say, okay, this is 25 degrees, this is 20 feet, and maybe this is 12 feet. Okay, you have to be given what? In order to use that formula, you got the angle, and then you have to have these two what? Sides. That side, that side. So what you need is what we call side angle side. So that my area formula is going to be 1/2 20 times 12 times sine of what? 25 degrees. So you're going to use this formula. And again, you want to know this is an oblique triangle. Non-right triangle. It's oblique. So you can do a little bit of simplification here because, you know, you can say 20 divided by 2 is 10. You say, Mr. Judge, is that 120 sine now of 25 degrees? That's what that is. Let's find out what we get now. So we got to go to the calculator. You got to go calc and say, what's going in the calculator? 120 sine 25 degrees here. What do you get here? 50 point what? 50.7. And that's going to be in units of area, so that's feet squared. Okay, feet squared. All right, ladies and gentlemen, take a look here. That's a area formula that's going to be very useful for us. All right, you guys okay with that? Easy peasy lemon squeezy here. Yes.
So it becomes feet squared because it's feet times feet?
Yeah. Square feet. Yep, it's feet times feet. Exactly. So remember, you say, what about the units? You've been always harping. Yeah, in science courses, they're going to really get mad. Feet times feet is going to be what? Feet squared. Feet to the second power. Exactly. So what do you guys think? Isn't that kind of interesting? You get a new area formula. It's like, wow. And even, just so you know, something like this, they can say, okay, what if this is going to be 80 degrees, and this is 5 centimeters, And then maybe this is 9 centimeters. So is this a side angle side situation, ladies and gentlemen?
Is that 5 centimeters or 8?
5 and 9. 5 centimeters and 9. So is this a side angle side situation, you guys think? How do we know? The angle, it has to be between, here's the angle. Is your angle between two sides? And, two adjacent sides? Is this an oblique triangle? Yep. Okay. So what does that mean? My area is 1/2 5 times 9 sine 80 degrees. And 5 times 9, isn't that 45? It's 45 halves sine 80 degrees. Now, you're going to enter this in your calculator. And you say, well, how do I do that? Well, you can do it this way. You can say this. 45 sine of what? 80 divided by 2. And you get 22 point what? What's your area approximately? 22 point what? To the nearest tenths. Go to the tenths. What do you guys get? Is that 22.2? All right, you guys okay with that one? Huh? Say that again.
I know that the area is like, like 1/2 base times height basically, but like shouldn't the 9 be in front of the 5 or something?
9 be in front of the 5?
Yeah.
No, it doesn't matter. Because multiplication is called commutative. You can say 5 times 9 or 9 times 5. Okay, and then, ladies and gentlemen, you have triangles that do look like this. And 120 degrees. 16 feet. 22 feet. What's so special about this kind of triangle, just so you guys know? It is a non-right triangle. Okay. But what happens with this here? I mean, what's the difference really between these two non-right triangles? There's a big difference. Right? What do we name this situation in geometry? You got 2. Remember this? It's acute or it is obtuse. Acute or obtuse. Oops. Acute or obtuse? Which one? Well, this one is acute or obtuse. What do you guys remember? This one is obtuse. Good. Because any angle that's bigger than 90 degrees, if it has an angle bigger than 90, it's obtuse. If all the angles are less than 90, it's what? It's acute. Remember that? Okay, you guys remember that detail? Now, how do we use the area formula here? I didn't prove it, but it's the same formula. 1/2, because you have side angle side here. So it's 1/2, just take any of the sides. 16 times 22, or 22 times 16, sine of 120 degrees. And so 22 divided by 6, or 16 divided by 22 is 8. So you can say 8 times 22, sine of what? 120 degrees. And then what's 8 times 22, by the way? Do you guys know? Well, let's find out. We don't have to find out. This is 8 times. Let's go to the calculator. 8 times 22 times sine of what? 120 degrees. What do you get? Is that 152? 152 point what? 4 square feet again. Feet squared. So, ladies and gentlemen, this is kind of a very nice way to compute area. And, part of it, there's going to be some interesting questions. Let's see if you guys are really awake. I'll tell you guys, here's a question for you. I don't think we could do it yet, though. Can we do it yet? No, not yet. So, sorry about that. I'm just thinking of a nice question. Actually, yeah, we can. See if you're awake. I want to draw a circle here. And where is my... Here's my center. Okay. This measures 135 degrees, and then this measures 4 units. Okay? Now, you guys know if that's the center of a circle, this also measures what? 4. Is that true? You know what they're going to ask? What is the shaded area? Now, this is actually a trig question. You go, why, Mr. Judge, is this a trig question? Does anybody know why this is a trig question?
Trick or trig?
Not a trick. Trigonometry. It's a trigonometry question. Why is this a trigonometry question and not a, you might say, no, that's a trig question. Anybody know? How do you get this area? Well, a couple of things. Yeah, I mean, we're going to do this. Let me say this to you guys. Have you ever watched how donuts are made? You might say, yeah, I think of a donut. How's a donut made, even though this is not exactly a donut, okay? But this logic is extremely important. I remember I was a kid and I used to watch how I was so amazed how donuts are made. Okay, what do you do with a donut? Do you guys know? You take all of this what? Dough, and you punch a hole in the middle. You remove it. Is that true? Do you guys know what I'm saying? And then the area on the left is equal to the equation of the areas there for the right. So in other words, whatever area you're looking for on the left side, you got to get this first area and subtract this what? The second area. So you guys know. So it's really A1 minus A2. So you guys know. You got two areas. So this reminds me of that. You say, what do you mean? Well, I make the claim. I'm going to try to get a color here. Maybe green, okay? Have you ever found the area? Oh, what did I do? What shape is that? That's not the right shape. What area is this? Is that a sector? What's the area of a sector? Isn't that 1/2 r squared theta? In green? Is that true? So the area in green is what numerically? Well, that green area, I guess I'm going to stick with the green. Okay? Right? You guys okay with this? It's going to be 1/2. What's r? 4 squared. What's theta? 135 degrees. What do I got to do with that? Pi over what? 180 degrees. I got to cancel out my degrees. Is that true? So the green area, 4 squared is 16. 1/2 of 16 is 8. 8 times 135 pi over 180. So far, so good for the green area. 135 pi times divided by 180. This is your homework from the past. Have you guys started your homework yet? I hope. What do you say? I'm going to start my homework, Mr. Judge, the night before the test. Or the weekend before the test. That's when I really start to do homework. I don't know. I think by that time it's too late. Right? That time you just might as well go to the movies or something. I don't know what's good. Okay, let's find out what that area is. Eight times 135 times, what's the value? Second pi. Divide by what? 180. What is this approximately in green? That's 18 point what? 8. I'm going to need to get my water. But that's not what they're asking, is it? They're asking for that shaded area. What do you guys have to throw out? We have to toss out the area of the triangle. Do you guys agree with that? So what I'm saying here, here's the idea. That area is the area of the sector in green minus the area of the what? Triangle in red. It always reminds me, even though that's not a donut, it reminds me of the donut analogy. How do you get the area of the triangle? What's that? Do you guys remember? Isn't that going to be what? Area of the triangle now in red is 1/2 AB. We got side angle side. Is that right? Side angle side for the triangle, that's 4 times 4. sine of 135 degrees. That's a side angle side situation. And then that's going to be 8 sine of 135. And what is that approximately? We'll see in our calculator. 8 sine what? 135 degrees. And what is this? This is about 5 point what? Is that 5.7 to the nearest tenths? Right? I think so. Is that 5.7? Okay. You want to know something, ladies and gentlemen? What's the deal? What's your area? Area is going to be this. (18.8), which is the area of the sector, minus 5.7, which is the area of the what? Triangle. What is that going to be? 18.8 minus 5.7. What is it? 13.1. And whatever units these were, I'm going to say units squared, okay? They're in feet, miles, inches, whatever. This is how you find the area, ladies and gentlemen, when you have a what? A sector minus the hole. The donut hole is a what? A triangle. So now you got the shaded what? Area. One of my favorite examples all in about area in all of ever. What do you guys think? So this is, this approach, like I said, the trigonometry just came in at the end here. That's when trig just popped up, ladies and gentlemen. Okay. So I'm updating your homework, and it's going to be in Canvas here. I'm going to do a little bit of some modification on it, but it's important to get started ASAP. Is that right? Because if you wait till the night before, what will happen? That's like a disaster. Oh, come on.
Will we have a study guide?
Yes, you'll have a study guide. Okay, so I'll see you guys tomorrow, and take care and stay safe, and you guys have a wonderful what? Wonderful day.